Hello YouTube, this is Dazza the cameraman. Today is Sunday the 10th of November 2013. This is a response video to one of my viewers, Edward Matthews, who has left a number of comments under my videos and also under other videos that I've been commenting on other channels. This is my video, Comet ISON update, 2nd November 2013. And as we can see, Edward has left a number of comments here, and let's say that they're not very polite, to say the least. And I'm usually pretty patient with people, and I put up with a lot of flack that people fire at me and call me names and all that sort of thing. You know, it's water off a duck's back to me, really. But this guy has called in some special attention on himself because of the way that he's been going off in his comments and swearing and really not being very polite. So here is a special response video just for you, Edward Matthews. I'm going to address some of the comments that you have made under my videos. You sort of raised some questions about what's going on with Comet ISON in particular, and your comments are generally all in the same vein, as that nobody really knows what's going to happen with Comet ISON because it's never happened before, you say. Now that's not actually true. I'd like you to tell me what it is that hasn't happened before. I'm not going to read your comments out because some of them are quite offensive and people can read them for themselves if they want to. But I just want to pick up on some of your points that you say that none of this has happened before, so no one really knows. Like in this comment here, I can read this one out. You don't know for sure. No one does, because it hasn't happened before in our lifetimes, although the interaction with the sun has got to have some effect. So my guess is as good as anyone else's, so stop talking like your info is all to end all. You don't know for sure, clown. Now I don't know if Comet ISON is going to survive its journey around the sun. Astronomers don't know that for sure. We're just going to have to wait and see. It's quite possible it could disintegrate as it goes round the sun, but even if it does, it will just carry on in its present trajectory and it won't pose any risk to the Earth whatsoever. We don't know how spectacular it's going to be, if it's going to be spectacular at all. Certainly the predictions for how bright it was going to be don't seem to have lived up to expectation, but that's quite normal for comets. You know, it's not unusual to see a comet and think that it's going to perform well, and sometimes it doesn't. But there are some things that we can be quite certain of, and this includes its trajectory, the path it's going to take around the sun, the path it's going to take as it exits the solar system again. These can be predicted very accurately by mathematical equations based on laws of physics that are well understood and have been well understood now for centuries. Before you start making claims that we don't know what's going to happen, you really should do some research on people like Johannes Kepler and Sir Isaac Newton, and learn a little bit about their work on the laws of physics and planetary motion. And the thing is that you are saying that nobody understands what's going to happen. Now I'm going to show you something in Starry Night Pro, and yes, this is a simulation, it's not a live view, but I'm going to show you some images that were live view shortly. Okay, so here is Comet ISON, and you're saying that nobody really knows what's going to happen because it's never happened before. This is the present position of Comet ISON as of right now, 10th of November 2013. It's just coming up to 0700 hours UTC, so we can see that Comet ISON is just coming up to the orbit of Venus. We can see the trajectory that is marked around the sun there. I can click on Comet ISON in this simulation, show the info, and here we see the information about its position in the sky. we can see the right ascension and the declination coordinates here. I can take these coordinates, go to the SLU space camera, or I can go down to the observatory, set up the telescope and punch in these coordinates for any time that I can go ahead in the future, like any date, and set these coordinates. And that telescope will point to these coordinates and I will see Comet ISON, because the data is accurate, and we know that it's accurate. And the fact that we can take photos of Comet ISON or any other comet that has been tracked, we can take photos of them based on these coordinates, and that proves that this data is accurate. Now, I have checked the NASA JPL data that I downloaded weeks ago, and we see that there is a very, very minuscule change of data, which is always expected. We're talking about an accuracy of like 99.99% sort of thing. The difference in accuracy is just not even worth mentioning. But you say that this has never happened before, that there's something new about Comet ISON and so on. Let's have a look at something else. We've got Comet ISON marked here. This is just a small selection of the comets that are currently in our solar system. There's actually a lot more than what we see here, but these are the main players. Okay. Now, these are the selection check boxes here. Let me just go down and we'll mark a few, and these are the ones that are currently within our solar system. As you can see, there are quite a few of them. There's probably a lot more comets in our solar system than people ever realize. In fact, presently there are more than 220 comets within our inner solar system. Our inner solar system is within the orbit of Mars. Okay, so that's a lot of comets, and most of them, the vast majority, of course, you would never hear about, would you? We only hear about the ones that may potentially put on a good show, such as Comet ISON. But Comet ISON, as it turns out, may be a fizzer. We'll just have to wait and see. Now, as you can see, it's taken me quite a long time to mark all of these comets. And as you can see, there's actually a lot of them, and each one of these comets is being tracked. And I can check the right ascension declination data. We can point a telescope at them and image them. That is if they're close enough. Some of them will be too far away to really show up unless you're using a really huge telescope. Okay. Now I've marked the selection check boxes. Let's just take that out a bit. And as I said, that's not all of them. That's just a small selection of them. But it gets more interesting than that. These are the orbit check boxes. Let's have a look at that. Let's switch on a few of these. And I won't need to turn on very many of them before you might get the idea. As I said, each one of these comets has been tracked, and tracked accurately. There are hundreds of comets within our inner solar system, and comets come and go all the time. It's nothing unusual. They're tracked by astronomers, and not only all the comets, but you've also got all the asteroids as well, which is another thing. And the asteroids are no different to the comets in that they can be tracked. Their trajectories, once they've been observed enough times, then their trajectories can be calculated very accurately. And it's no surprise that when we look at all of these comets and asteroids, that we can see it looks like it's a wonder that we never get hit. I mean, look at that. It looks like a big ball of wool. Look at that. Now each one of these comets has been tracked, and you can't tell me that this has never happened before. Please explain to me just what it is that hasn't happened before, because I'd like to know. And by the way, back in 1910, the Earth passed through the end of the tail of Halley's Comet. And back in 1910, the doomsayers were saying all of the same things that the doomsayers are saying today. That life will be snuffed out by cyanide gas, cyanogen, in the tail of the comet. And they made some pretty good money selling comet pills and comet umbrellas and things like that to gullible people at the time. So, as I say, please explain to me just what it is that hasn't happened before. Oh, and by the way, I did promise that I'd show some what were live images. And you claim that the atmosphere of Mars has been changed by Comet ISON. No, it hasn't. Here are some very good images of Mars that were taken by astronomer Damien Peach. These images were taken on the 20th of September 2013, and as we can see, Mars looks quite normal. He also took some images on the 6th of October 2013, and as we can see, Mars looks normal. If we flick between the images, we don't see a lot of difference. Any difference that we do see has probably got more to do with the weather conditions at the time here on Earth. Okay? And my point being was that the images that people were looking at were either not real or they didn't understand what they were looking at. When I was talking about images that were not real, I'm talking about images that were not really Mars. In other words, they were looking at something else, or possibly they were looking at Mars, but the image was overexposed and that caused bleeding and all sorts of things. Mars is a difficult planet to image because of its size and its colour, and you do need a very good telescope and very good imaging equipment to get good images of Mars. These images by Damien Peach are very good, and they show quite clearly what Mars should look like. And Mars has not reacted to Comet ISON. It hasn't gone into a coma, as some people have claimed. It hasn't changed its atmosphere. Mars is exactly as it should be, and exactly as it always has been. So I hope that's cleared that up for you. As I say, please explain to me what it is that has never happened before. I would really like to know. As always, do check out my Facebook discussion page, Voices of Reason to Explain X, or VORTEX. You'll find a link in the description area. Thank you for watching.